Electric charges and electric field. Now to see one topic. When a charge considered as a point question mark, when the linear size of the charge body is much smaller than the distance separating them, the size may be ignored and the charge body are treated as point charges. How did Coulomb find the law of electric force between 2 point charges? Question mark. Coulomb supposed the charge on metallic sphere to be q, small q. If the sphere is put in contact with an identical uncharged sphere, the charge will spread over the two spheres. By symmetry, the charge on each sphere will be q by 2. Repeating this process, we can get charges q by 2, q by 4 etc. Spheres with pairs of electric charges of q by 2, q by 4, q by 8, dash 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 are obtained by repeating this process. Coulomb varied the distance for the fixed pair of charges and measured the force for different separations. The force acting between two charges is directly proportional to the product of charges and inversely proportional to the square of the distance between them. F proportional to q1 q2 equation number 1 and F proportional to 1 upon r square equation number 2. By combining the equation 1 and 2, we get F proportional to magnitude q1 q2 upon r square equation number 3. Equation 3 is known as Coulomb's law. Therefore, F is equal to K in magnitude q1 q2 upon r square equation number 4, where K is known as Coulomb's constant. Write Coulomb's law and explain its scalar form. The electric force between 2 point charges varies inversely as the square of the distance between the charges, and is directly proportional to the product of the magnitude of the two charges and acts along the line joining the two charges. You can see in figure, point charges q1 and q2 are at the distance r. Thus, if 2 points charges q1 and q2 are separated by a distance small r in vacuum, the magnitude of the force F between them is given by F proportional to magnitude q1 q2 upon r square. Therefore, F is equal to K magnitude q1 q2 upon r square equation number 1, where K is proportionality constant and also known as Coulombian constant. Experimentally, it is found that K is equal to 8.9875 into 10 to the power 9 Newton meter square upon Coulomb square. In general, it is taken as K is equal to 9 into 10 to the power 9 Newton meter square upon Coulomb square. K is equal to 1 upon 4 pi epsilon 0, where epsilon 0 is equal to permittivity in free space. K is equal to 1 upon 4 pi epsilon 0, where epsilon 0 is equal to permittivity in free space, is equal to 8.854185 into 10 to the power minus 12 Coulomb square upon Newton into meter square, is equal to 8.9 to 10 to the power minus 12 Coulomb square upon Newton into meter square. Hence, electric force is free space. F is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square equation number 2. If the charges are at the distance r at any medium instead of free space, then electric force in medium Fm is equal to 1 upon 4 pi epsilon q1 q2 upon r square equation number 3, where epsilon is equal to permittivity in medium. Fm is equal to 1 upon 4 pi epsilon q1 q2 upon r square equation number 3, where epsilon is equal to permittivity in medium. Now, relative permittivity is equal to epsilon r is equal to epsilon upon epsilon 0 is equal to K is equal to dielectric constant. By taking ratio of equation 3 to 2, Fm upon F is equal to epsilon 0 upon epsilon is equal to 1 upon epsilon r is equal to 1 upon K. Therefore, Fm is equal to F upon K. Thus, electric force between two charges in a medium is 1 upon K times the electric force in free space. By using Coulomb's law, define unit charge. In SI, the unit of charge is coulomb. Putting value of Q1 is equal to Q2 is equal to 1 coulomb, R is equal to 1 meter. In F is equal to K Q1 Q2 upon R square. Then F is equal to 1 upon 4 pi epsilon 0 is equal to 9 into 10 power 9 Newton. Definition of 1 coulomb is that charge which when placed at a distance of 1 meter from another charge of same magnitude in vacuum experiences an electrical force of repulsion of magnitude 9 into 10 power 9 Newton. For convenience, we use K is equal to 1 upon 4 pi epsilon 0. Coulomb's law, F is equal to 1 upon 4 pi epsilon 0 into Q1 Q2 upon R square. Epsilon 0 is called permittivity of free space. The value of epsilon 0 in SI unit is epsilon 0 is equal to 8.854185 into 10 power minus 12 coulomb square upon Newton into meter square. And K is equal to 1 upon 4 pi epsilon 0 is equal to 1 upon 4 into 3.14 into 8.85415 into 10 power minus 12. Therefore, K is equal to 8.9875 into 10 power 9 Newton meter square upon coulomb. We use K is equal to 9 into 10 power 9 Newton meter square upon coulomb. Write the limitation of Coulomb's law. First, charges should be point charges. Second, charges should be at rest. Third, distance between charges should be greater than 10 power minus 15 meter nuclear radius. And fourth, distance between charges should be less than 10 power 18 meter. Explain vector form of Coulomb's law and its importance. You can see in figure a geometry. Second, force between charges. You can see here, suppose point O, the charges Q1 Q2 at the having a position vector R1 and R2, and resultant, that is R21 is equal to vector R2 minus vector R1. Here the force on Q1 is F12 due to Q2, and the force on Q2 due to Q1 is that F21. In figure B, Q1 Q2 greater than 0, so Q1 and Q2 having a repulsive force, that is F12 and F21, and second figure Q1 Q2 less than 0, then the force will be attractive, that is F12 and F21 towards each other and having a unit vector R21. Suppose the position vector of Q1 and Q2 are vector R1 and vector R2 respectively as shown in the figure A. Let force acting on Q1 by Q2 be F12 vector and force on Q2 by Q1 be vector F21. If 1 and 2 numbers are given to Q1 and Q2, then vector R21 is the position vector from 1 to 2 and vector R12 is position vector from 2 to 1. By using triangle method for vector addition, vector R1 plus vector R21 is equal to vector R2. Therefore, vector R21 is equal to vector R2 minus vector R1, and R12 vector is equal to vector R1 minus vector R2 is equal to minus vector R21, and magnitude of vector R12 is equal to R12, and also magnitude of R21 is equal to R21, and the magnitude of vector R12 is equal to R12, and also magnitude of vector R21 is equal to R21. Therefore, unit vector R12 is equal to vector R12 upon R12, and unit vector R21 is equal to vector R21 upon R21. Force acting on Q2 by Q1, vector F21 is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R21. r21 square into unit vector r21, and force acting on q1 by q2 vector F12 is equal to 1.4 pi epsilon 0 q1 q2 upon r12 square into unit vector r12, but unit vector r12 is equal to minus unit vector r21, therefore vector F21 is equal to minus vector F12. Write some important points for vector form of Coulomb's law. First, vector F21 is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r21 square into unit vector r21, number 1, and the equation is true for both positive and negative value of q1 and q2. Second, if q1 and q2 both are positive or both are negative, then vector F21 is in the direction of vector r21, which shows repulsive or like charges. Third, by replacing 1 and 2 in above equation 1, vector F12 is equal to 1.4 pi epsilon 0 q1 q2 upon r21 square into unit vector r12 is equal to minus vector F21. Fourth, Coulomb's law agree with Newton's third law. Fifth, if the two charges are placed in a medium, then the force between them becomes 1 upon k times, means Coulomb's force decreases, k is equal to dielectric constant. 6, Coulomb force are central forces, means they pass through line connecting centers of the charges. 7th, Coulomb's law is inverse square law. 8, according to the law, electric force is of the two types, attractive and repulsive. And 9, there is no effect on third charge on electric force between two charges, thus Coulomb's law is called the two-body force.